Chapter 6. How does red light heal? Every one of the estimated 37.2 trillion cells that make up the human body contain tiny structures within called mitochondria. These organelles are responsible for energy production by the cell in a process called metabolism. The following image depicts two healthy mitochondria floating inside a mammalian lung cell, photographed via a transmission electron microscope. When a cell is given everything it needs to metabolize properly, a process involving the chemical oxidation of glucose into carbon dioxide within the mitochondria, the cell is healthy. It is the breakdown of efficient metabolism within cells and tissues that heralds cancer and other diseases in the body. Nearly every disease state known to man has been linked to low mitochondrial activity. Understanding which foods and factors enhance metabolism and which inhibit it are paramount for successfully preventing or reversing disease. Lowering metabolism with environmental toxins. One important thing to understand about cellular metabolism is that every step of the process is catalyzed by a specific enzyme. One such enzyme is called cytochrome C oxidase, which was discovered in 1926 by Dr. Otto Warburg, who went on to receive a Nobel Prize for his discovery. This enzyme is critical for oxygen use by cells because it interacts directly with oxygen and catalyzes the very last step in the process of metabolism, called oxidative phosphorylation. Dr. Warburg found that simply by inhibiting cytochrome C oxidase, a healthy cell could be turned into a cancer cell, a finding which has been validated by a number of recent experiments. Defects in cytochrome C oxidase expression induce a metabolic shift to glycolysis and carcinogenesis, wrote scientists from the University of Pennsylvania in 2015. A number of chemical toxins have been shown to inhibit cytochrome C oxidase activity, including chemotherapy, cyanide, carbon monoxide, aluminum phosphide, estrogen, serotonin, endotoxin, aflatoxin B1, UVB radiation, X-ray radiation, and unsaturated fatty acids. Here's how it works. Upon exposure to any of the environmental contaminants listed above, cells produce a free radical called nitric oxide, which binds directly to cytochrome C oxidase, deactivating it. For as long as nitric oxide is bound to this enzyme, the cell will have a defective cancer metabolism. Enhancing metabolism with red light. The impacts of red and near-infrared light on cellular metabolism are fascinating and unique. Remarkably, red and near-infrared light have both been proven to actually unbind nitric oxide from the cytochrome C oxidase enzyme, restoring its activity. But the truth is even more incredible. Cytochrome C oxidase is unique in that it actually absorbs light specifically within the red and near-infrared portions of the spectrum. Not only does red and near-infrared light liberate the cytochrome C oxidase enzyme from an inhibition by nitric oxide, but it also directly energizes this enzyme, which supercharges its activity. The result is enhanced cellular metabolism and a cascade of beneficial physiological effects that emerge from increased metabolic activity, including increased energy ATP production, increased cellular oxygenation, increased blood flow in the body, increased CO2 production, reduced stress hormones, reduced lactic acid, reduced inflammation, and reduced free radicals. It's this cascade of beneficial physiological that can account for most, if not all, of the broad-ranging beneficial effects of near-infrared and red light therapies. Summary: red and near-infrared light penetrate deeply into body tissues, where they impart their healing effects by enhancing mitochondrial energy production.